Sorry about that. A little technical hiccup there. We are moving on to number 3. Again, we're 3.2 solving systems by substitution, example 3 here. Again, this one is set up nicely for substitution method, although it's a little bit more difficult than the first 2 examples that we did. I now have to substitute all of this in for y of the second equation. So let's do that. 5x plus 2 times 5x minus 5 equals a negative 10. Now I got to distribute my 2 there. So 5x plus 10x minus 10 equals a negative 10. I can combine my like terms there to where I have 15x minus 10 equals. So I don't know how I got that there. That was a negative 10. All right, so equals a negative 10. Add 10 to both sides. Cancels. It actually cancels on both sides. So I end up with 15x equals 0. Divide by 15, so x equals 0. Now that I have one of my variables, the actual value of it, I can substitute it back into one of the original equations. For me, I'm going to put it into the top one. So now I have y equals 5 times 0 minus 5. So y equals 0 minus 5, or y equals a negative 5. Now I have both parts of my solution, and my point of intersection is 0, negative 5. And that's solving it algebraically by substituting one value in, finding a value for a variable, and then substituting that one back in. And we can like this method because it's a lot more accurate than graphing, and again, unless you're using technology. Let's try it again. Again, the y is solved for, so this is set up beautifully for substitution. I'm going to substitute that value in for the y in a second. Now, it's very important I substitute it in for the y because that's what y equals. Okay, so I got negative 6x plus 2 times, in this case, 3x plus 16, and that equals 32. Distribute, so negative 6x plus 6x plus 32 equals 32. And now simplify, I can put those two together. Negative 6x plus 6x cancels. So I end up with 32 equals 32. And at this point, just like earlier in the unit, you may think, uh-oh, I've done something wrong. No, not at all. When we get something like this where two numbers equal each other, remember that means infinitely many solutions. Just like if we had gotten 4 equals 3, that would have been no solution. Okay, so this can happen. So basically what's happening here is this means that if we were talking about a graph, we would have 2 lines that were directly on top of each other. Infinitely, basically the same line. So that's possible as well. So again, we're solving by substitution, and every one that we've done so far has been set up beautifully for substitution. Let's look at our last case. And in this last case, we can see that no variable is by itself. No variable has a coefficient of 1. So I get to choose which equation I'm going to simplify or get the y alone. Basically like we did earlier in the unit where we solve for a variable or put it in slope-intercept form. I'm going to choose this top one just by looking at my coefficients. Those 3's are all multiples of each other, and I can tell I'm probably not going to have any fractions, where on the bottom side, if I were to do those 3, those numbers don't go in evenly. So now this is just me thinking ahead and realizing which one's going to be a little bit better. So let me take this first equation and solve for the y, because that's what I'm used to doing, getting that y alone, right? So I'm going to add 3x to both sides. So I have 3y equals 3x plus 3. Now I can put that 3x on the back side, which some people do, but I just like having my variable first. Now I'm going to divide by 3 so I can get this y alone. Divide by 3, whatever I do one side, I do the other. So I end up with x plus 1. Now that I have this y by itself, that's good. I can take this value and I can plug it in for y in the second equation. Let me do that over here. 12x minus 5 times x plus 1 equals 16. Okay, let's distribute. 12x minus 5x minus 5 equals 16. Combine my like terms there. 7x minus 5 equals 16. Let's add 5 to both sides. 7x equals 21. Finally, that's 7 times x, so divide by 7. Divide by 7, x equals 3. And now I have my first value. I'm going to take that value. Now I can plug it into any one of the 3 original equations. I can plug it in there if I want. I can plug it in here, or I can even plug it into that one. This one over here looks the easiest to me, so that's the one I'm going to choose. So y equals 3 plus 1, or y equals 4. So my solution then is 3, 4. That is using the substitution method to solve systems of equations. Good luck with you, or good luck to you in finding your solutions to your systems. Have a great day.